This is covering Lab 6. So Lab 6 is mostly involved in recursion. Problem 1 is about more digit manipulation, which you guys should be familiar with from previous labs as well as the homework. Part 2 is where you are going to take your code from problem 1 and change it into recursive code. You guys should be familiar with recursion from class as well as from 180 and 181 if you took those. I think an important note about recursion, especially involving this lab, is normally recursion is only useful for the programmer, making code a little easier to write, except for a select few problems which can only be solved through recursion. Most of the time, recursion is going to make your code less efficient. So if it can be solved in an iterative way, as this problem can be, usually it's better to do it unless it's significantly harder to program, in which case your time might be more valuable. This is one of those instances where the problem is much easier to do through iterative means, but we are using recursion for it for practice. Okay, so let's say I have a simple program here. I'm just printing out the values of I. We can see that I print out 0 through 4. Now I'm going to go through a couple examples of how to change these iterative programs to recursive. So first thing I'm going to do, I consult my loop and I say, well, I guess the really first thing I should do is make my recursive function. So I'll just call it rec. We see I have one variable I and I'm printing it. So I know I need a print statement and I'm going to be printing some value. So I'll use I because it's the same for consistency. I know I need to print incrementing values of I. So that means I can't just set I equal to something here. I need to increment it on each call of this function. So it makes more sense to pass it in as an argument. Next, it's a recursive function. So I know I need to call the function again. And I know, again, because it's a recursive function, I need to have some base case. And I only call, or I suppose it's the opposite of the base case, where I only call the recursive function again if it meets some condition. And this condition is actually really easy. I can just lift it right out of the for loop. You can see I only run the for loop while I is less than 5. So I can do the same here. I can only run the recursive function while I is less than 5. And then I need to decide what to pass in to rec because it takes an argument. I know I want to increment the value of I at each iteration. So what I can do is instead of passing I, this would always print the same value. I can pass in I plus 1. So now every time I call rec, I'm incrementing the value of I, just like in the for loop. So now let's think about what's happening here. I call the function with some value. Let's say I comes in as 3. I print out the value of 3. 3 is less than 5, so it's going to call this again, and then it's going to call the function again with 4. 4 gets printed out. 4 is less than 5. Function gets called again with 4 plus 1, which is 5. Prints out 5, and here's where we run into trouble. My original function did not print out 5. So that means this runs for one too many iterations. So I can either change that to 4, or more simply, I can just move the print statement into the opposite of the base case, I guess. So now let me comment this out. Actually, what I'll do is I'll print out both of them. All right. And now I need to call the rec function. And I got to decide what to what the initial value of I should be. And I don't really need to decide because my for loop already tells me that it should be 0 at the start. So I can have it as 0 at the start, recompile, run it, and we see my recursive function runs as 0, 1, 2, 3, 4, and my iterative function runs as 0, 1, 2, 3, 4. So these two are acting the exact same way. Okay, so now let's go through another example. Let's say instead of just printing out I want to take the sum of I, as we did in lab 5. So this should be familiar. I increment sum. Let's get rid of that print statement. And let's print out the value of sum at the end here. Run it, and I get 10. Yes, that makes sense. So I have all values incrementing from I equals 0 to I is less than 4. So that's going to be 0 plus 1 plus 2 plus 3 plus 4, which is going to be 10. So now let's make this recursive. And there's a couple of different ways to do this, so I will go over both of them. Okay, so let's see. I want this whole thing to evaluate to a single number. So it makes more sense for me to return something here. It makes more sense for my function to actually return the sum. And I'll call it rec sum I because I'm taking the recursive sum of I. Just like before, I have I, so that's incrementing each time. So I should probably take in I as an argument. I'm going to need my base case, and I'm going to need to call this again. And just like last time, I can say I plus 1 to iterate I. And my base case, again, just like last time, I can make the same as this. Okay, now I have to decide what I actually need to do here. So again, there's two different ways to do this. I'm going to go over the more naive way first, and then I'll show a slightly cleaner way to do it. So I have this sum variable as a new variable, so it also makes sense for me to add it as an argument here, and then I can take it here and say, well, listen, my sum can be, I know I need to add I to it eventually, but I also need to consider all values before. So I need to consider sum is not just the value of the current I, it's going to be the value of all i's. So I need to somehow get the value of I through all the sums. So I can say sum plus I here, and I can take the sum and maybe I can return sum or return rec sum I. Let's just see where this gets us. I find oftentimes that you can think about the problem to get most of the way, and then maybe just try some stuff to fine tune it. So let's get a print statement for this sum. We see I initialize I and sum to 0, just like I did before. Let's run this, and I get 10. So that actually worked. That worked first try. And we can kind of see how it's working every time I either return sum, which is that base case where I is greater than 5, and in that case the sum is going to be equal to well, it should be equal to all of the previous sums plus I, because every time I pass in sum, I'm incrementing it by I. So on this final case, I'm returning sum, which should be that sum, that initial sum, which is 0 plus all of the i's as I go through these functions. So this makes sense why this works. But again, we can simplify this even a little bit more. So instead of passing in sum as an argument, let's not pass it in as all. And then right here, I can say int sum, and then I can say sum equals, and then let's say, there we go. So let's consider what this is doing. Actually, I'll change that around to I. There we go. And change this to plus. Perfect. Okay, so now let's consider what this is doing. I know I have my initial sum, which is going to start out as 0, and then I'm adding the return value of all following sums, and then I'm returning sum. So this function is going to similarly initialize sum to I. So on the next iteration, it's going to be I plus 1. So sum is going to be initialized to 1, and then it's going to be returned as 1 after adding all of the following ones. So we can see how this sum is going to build up and build up and build up in this function call before finally being returned as sum. And let's see what we get here. 15. So it looks like it's going 1 too far. It looks like it's adding 5 as well. And that makes sense because I'm setting sum equal to 0 here. So even on the case where I is equal to 5, 5 is still being returned. So by moving that I in here, I'm making sure that I is only added when it's less than 5. And there we go. Now we're back to 10. Nice. And if you really want to overachieve, we can even mess around with this a little more. There's actually no need for this variable. We can reuse the value of I. I believe. Oh, so close. And again, we run into that same problem where if I is equal to 5, I'm returning 5, and that's not what I want. So if I return I here and 0 here, there we go. Now I'm back to 10, and I didn't even use the sum variable. And I can simplify this even further by just returning I plus this. There we go. So we can see that now this was a bit of a stretch, I'll say. So rewatch that part of the video if you need. It can get a bit confusing. So that's why I decided to show off the naive version of this function to start out with, where we pass in the sum as well as I, because that makes the most logical sense as far as just converting a for loop to a recursive function. But know that there are other options a lot of the time, and you can make these really elegant functions. Okay, that's all I've got for Lab 6. Best of luck with it.